In this lesson, we're going to be evaluating trig functions again, but this is just more of a true-false. So we're going to want exact values, which means we're going to be pulling information from our special right triangles, or potentially we're going to land on an x-axis or a y-axis. So we need to remember that sine are our y's, cosines are x's, and tangents are y's divided by x's. And then this, again, refers to what quadrant we're in, makes our values positive or negative. So all your trig functions are positive, sine is positive, tangent's positive, cosine's positive. All right, so some true or false questions, and actually these will be future properties, some of them, because some are true, some are not true, but they are some trig identities that is something further down the road. So is sine of 30 degrees plus sine of 60 degrees equivalent to sine of 30 degrees plus 60 degrees? So are they the same thing? You know, like could you add the angles together and it would be equivalent to it? Is there a shortcut? Well, this is really sine of 90 degrees. All right, so sine of 30, sine of 60. Here's our triangles. Sine of 30 is going to be 1 over root 2. Sorry, 1 over 2. Plus sine of 60 is going to be root 3 over 2. All right, so there's the left side. Sine of 90 is going to land us on the y-axis up here. Sine's the y value, which is 0. Nope, 1. That's the x value. Y value is 1, so that is 1. So is this the same thing as that? No. You have a common denominator, so 1 plus root 3 over 2 does not equal 1. So that is false. All right, what if we take something similar where it's going to be sine squared of 30 degrees plus cosine squared of 30 degrees? Is there any possible way that that thing adds up to 1? Well, let's find out. Sine of 30 is 1 over 2. And then you're going to square it. Cosine of 30 is root 3 over 2, which actually is the same thing as sine of 60. They're co-functions. And you're going to square it. Does that add up to 1? Well, when you square a half, you're going to square the top, square the bottom. So that gets you a 1/4. Here, same thing. You're going to square the top, square the bottom. Does it add up to 1? So 1/4 plus 3/4 is 4/4. Does it equal 1? True. And actually, this is a Pythagorean identity that you might have seen or you remember, that it's actually sine squared theta plus cosine squared theta equals 1. So it doesn't matter what angle you plugged into this as long as they were the same. So it could have been sine of 89 degrees and cosine of 89 degrees. Something that I couldn't even pull from the special right triangles wouldn't matter. As long as the angles are the same, 100% of the time it's going to add up to 1. All right, so we got one last. And then again, I'll probably need that information, so we'll make sure we have it. Cosine of 2 times 45 degrees is really cosine of 90 degrees. So 2 times 45 degrees, is that the same thing as 2 times cosine of 45 degrees? Doesn't feel like that's going to work out. Because now you're turning into cosine of 90 times 2 cosine of 45, where I doubt they're going to have that kind of relationship. But cosine of 90 is landing us on an axis. So cosine is our x value, which is 0, which already I'm highly doubting that thing's going to work out. Cosine of 45 is adjacent over hypotenuse. So that's going to be 1 over root 2 times 2. I need to do a little bit of cleanup on that. I'm going to rationalize my denominator. The bottom line is it's not going to be 0, but let's clean this up a little bit. If I rationalize my denominator, I'm going to get 2 times a root 2 over 2, because that turns into a square root of 4. Square root of 4 is 2. And then that 2 and that 2 can simplify each other. So does 0 equal root 2? No. Now there may be special cases to this, but the majority of the time I don't think that's going to work out. All right, that was just a couple examples of evaluating some trig functions. This was more of just kind of testing if some properties were true or not.